Hey, what's up guys, my name is the Cherno. Welcome back to another code review, the series in which you guys send me your code and projects and all that stuff, and I take a look at it. So last time we were on Linux taking a look at a voxel rendering kind of engine, so check out that video, I'll have it linked up there if you wanted to catch up with this series. Today we're taking a look at something that I think is going to be really interesting to a lot of people, and we're back on Windows. What's this? Your computer will restart. So this time around, we have Makar Ivashko saying that your series about Hazel Engine motivated me to finally do my own engine as well. It's a software ray tracing engine supporting reflection, refraction, area light, soft shadows, polygon mesh rendering. So I would be very grateful for a code review. There is also an informative readme with pictures in the repository, and here is a link to the repository. As always, I will have that link in the description below in case you guys also wanted to check it out. Now, I thought this would be kind of interesting because whilst we have looked at engines in the past, we really haven't looked at any ray tracing engines. And for those of you who don't know, ray tracers typically do not run in real time, and especially not a software ray tracing engine. So software ray tracing means that it's done on the CPU, not on what we call hardware, which, I mean, a CPU is also like a piece of hardware, but hardware usually refers to GPU, or the graphics processing unit, so your graphics card. This, on the other hand, is a software ray tracing engine, which kind of makes it seem like it is in fact done from scratch. A lot of people don't really perceive hardware programming as a from scratch because you're usually using like a graphics API like Vulkan or OpenGL or DirectX. Whereas if you do things on the CPU, you're typically just programming basically just like mathematical equations that contribute to a pixel kind of array, which to a lot of people is kind of a lot more bare bones. There's no kind of worrying about what the graphics card is doing or having to use their APIs. You can kind of more or less focus on the actual algorithms and the mathematics behind that stuff instead of worrying about an API like Vulkan or OpenGL. That's if you compare it to something like doing this in a compute shader in Vulkan, where you would have to worry about like where the compute shader fits into the pipeline, how to get data to the compute shader, how to then get that texture and render it as part of like a graphics pass so that you can see it on the screen. It's like a whole thing, right? So this is definitely going to be a lot more simple and to the point, which is something that I like to see. Now, let's quickly, like, I'm just going to gloss through this. I'm not going to read this in front of you guys. Again, the link to this is in the description below if you want to read everything. It's written fully in C++17, which is interesting. It looks like CMake is important. However, actually, if you're using Visual Studio, it looks like it does in fact include a solution file, so we'll just be able to open it in that. And yeah, it looks pretty cool. So let's take a look at this in more detail. Wow, he's actually got a pretty decent like README. This is looking good. But before we jump in and take a look at this project, I want to thank Skillshare for sponsoring this video. For those of you who don't know, Skillshare is an amazing online learning community where millions of creative and curious people from all around the world can come together into a community and learn new skills by taking a class on almost anything imaginable. Whether you're interested in photography, videography, animation, illustration, marketing, business stuff, productivity, they literally have everything on their platform, and all of their classes are incredibly high quality, concise, to the point, no fluff, no Cherno style videos, no just good videos. They don't have to worry about YouTube and the algorithm and likes and comments and don't forget to subscribe. No, their videos are actually perfect for learning. I've been using Skillshare here and there for little things that I've wanted to learn, such as concept art for an upcoming game I may or may not be working on, and other things as well, such as YouTube and how to make better videos. If you would like to check out Skillshare, you're in luck because Skillshare is offering the first 1,000 people who click the link in the description a 1-month free trial of Skillshare Premium. So you can check out literally all of their classes for a month and see if there's anything there that you like. So definitely click the link in the description below. There's no reason not to. Check them out. Huge thank you as always to Skillshare for sponsoring this video. So what I've done here is I've cloned the repository. Just a little quick tip. Whenever I clone, I tend to clone recursively just in case there are like Git submodules that I also need to fetch. Looks like there weren't any in this repository, but just a little tip, because I've seen a lot of people not clone recursively and then wonder why things don't work out of the box. That's the reason that it might not work. Now, speaking of working out of the box, last time I had to fix the project, so let's see how good this goes. And I vowed that if someone was to send me a project that didn't work again, I would be extremely upset. So let's go ahead and try and build this, see if it builds. Let's find the main file, and looking good so far. All right, guys, let's bring it in. Let's bring it in. This is about to become a tutorial on files and working directories because I see this way too much. One of the biggest problems when learning programming, and I used to do this. This is also a personal story about what I was like back in the day. People just seem to struggle with files, loading files. Like if I want to load a file in Java or C++ or some other programming language, like how do I load the file? If I don't use some kind of absolute path, what is it relative to? I have no idea why like this doesn't seem to specifically be taught. I'm pretty sure I was never really taught about the concept of a working directory, but let's dive into this. So the first thing is, obviously, for those of you who don't know, this is a problem because this is something we call an absolute path. Absolute path because it kind of begins from the root, right? This begins from the D drive and then it goes into the dev directory and then CG and ray tracing. The thing is, I do have a D drive, but I do have a dev folder. This is all very suspicious, but I do not have a directory called CG, and this is certainly not the directory of. This file does not exist on my computer. On the person who actually wrote this, presumably it does. But the bigger problem is there's no actual reason to ever write code like this. In fact, absolute paths are something you absolutely want to avoid. In certain situations, they may be required because you might have certain files on your computer in different places. Usually you would maybe set an environment variable and then require to kind of access that environment variable if you need to like get a path of something else on your computer. That's kind of specialist cases. For the most part, there's no reason for this part to be here. We need to be able to open this file in a more relative sense. So when I write some C++ code to open a file, how do I create a relative path? Like what is that path relative to? Well, to understand that, you need to understand something called the working directory. In Visual Studio, if we right click on the project and go to properties and then debugging, you can see we have this thing called a working directory under the debugging properties. This is currently set to a macro or a variable called project dir. Now, what that macro is the actual location of this project file on disk. This vcxproj, because that's our ray tracing project file, that directory, so in this case, C dev YouTube code review ray tracing, that is what this is, right? And if you have any doubt as to what this is, you can of course edit it and see what the macro expands to. In fact, you can see what all of the macros expand to. So if you wanted to know what the solution directory was, in this case it's the same, you can see the value of that macro here. Very important stuff. So that means that when I run this through Visual Studio, right, in this case the debug configuration on the x64 platform, right? I mean, this will be the same for all configurations. The point is it will set the working directory to be that project directory. So if I open up that directory again, you can see that this is now my relative kind of root. So if I then just go input slash, shotgun.scene, right? Which in this case would just look like this, or I could use forward slashes instead of backslashes, and I guess forward slash is what I mean. This is also technically maybe a slightly better way to write this because forward slashes work on all platforms. I'm actually not sure, depending on what C++ API you use, it might actually work even on like Linux if you do this, or on Mac, but for a more portable way, you always want to use forward slashes with like file paths. So this path now is in fact going to work because, again, our working directory is this, and if you pass in this actual path, you don't modify it at all into like, std if stream or something like file, and then you do like, fopen, right? Fopen, then that's gonna work, right? Because again, it's relative to the working directory. But wait, there's more. A lot of people get confused by this because if you actually go into the exe file directory, right? So when we actually build this project, it obviously outputs an exe file, which is what we end up running. If you try and launch it here, it's not going to work because the working directory is now no longer what Visual Studio says it is when it runs your actual application. The working directory is not the project directory anymore. It's this actual directory with the exe file. And so that's why people also get confused. They end up not knowing which directory the assets should be in. Should they be in the directory with the exe file? Should they be in the directory with the project file? And so sometimes they decide, oh yeah, it has to be both, because if I want to distribute this application, I want it to be alongside the exe file. That's mostly true. However, if you are just testing this exe file outside of Visual Studio, what you can actually do is create a shortcut of the exe file. Then if you go into properties, you can modify this start in parameter, right? So instead of this being this actual directory that contains the exe file, you can actually change it back to be the directory of the project file. And so now if I launch this shortcut, it's going to set the working directory to be the same as what Visual Studio sets it at. So that means that I don't have to copy any assets, because you definitely want to avoid copying assets. I would never do that. You have to keep them in sync. Some people do like a post build step, which is it's just slowing down your build for no reason. Don't do that. Just run this shortcut. Of course, if you're packaging it for distribution, that's a different story. One final thing I want to mention is you can also programmatically check and set your working directory. Now, since this project is C++ 17, you can actually use the brilliant file system API, which I love. And if you actually execute this function, std file system current path, you'll see it takes no parameters, which lets you actually check what that current working directory is, but then you can also set it to be something. So if you wanted it to be like some kind of working directory or whatever, you can actually write code like this and it will programmatically change your working directory to something else. We use this in Hazel for a number of different kind of scenarios in which we actually want to allow the application or the game to set its own asset directory and stuff like that. But the point is that's also possible, right? So there are a number of ways to kind of control where your files are relative to, but I hope you enjoyed this little tutorial. Maybe this should have been a standalone video, but anyway, working directories, that's how they work. I don't want to see any more absolute paths from any of you. Please just be aware of this, because it is a little bit of a tricky thing in the beginning, and I definitely struggled with this in the past, especially because I mentioned Java in the beginning, and Java has this whole concept of like, you know, of files being within the jar file, and then that's like a entirely different story. But anyway, we won't touch on that. So now that we can actually potentially run this, let's just go ahead and run it, and we'll dive in and take a look at the code. Exception thrown. Nothing ever works. Okay, well, let's go ahead and fix this, because as usual, these code reviews are also not just reviewing the code, but also hopefully sharing a little bit of how I debug problems and how I approach things. Actually, one thing I want to mention is that, like, you know, a lot of people find code on GitHub, and the code itself might be decent, but they download it, and especially if you're a beginner, you kind of just expect that code to work. Like, you want to be able to download it, hit F5, it works, everything's fine. But the reality is sometimes you just need to tweak some things, right? And again, usually it's the fault of the author, the person who puts their code online. I mean, sometimes they don't intend people to, you know, actually look at their code. They're just doing it for themselves, although if that were the case, they wouldn't be sending an email to chernoreview@gmail.com. But anyway, the point is, I made a video a while back about the best way to like learn C++ and get better at it. I'll link it up there if you want to check it out. But my point is that in that video, I said one of the best ways to learn C++ more is to actually look at other people's code. Like, you need to be doing that. But other people's code doesn't work all the time. So hopefully these little kind of debugging sessions are a way for you to kind of get a glimpse of how I approach these kinds of issues. I mean, sometimes there's just no fixing something because you're not going to spend like days fixing it. But in this case, it's probably something trivial, I expect. I have no idea. So let's take a look at it, and hopefully this will be helpful in some way. So what's the problem? I like to look at the exception. If we look at the output window, it says that there's an access violation, reading location, blah, 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 3C. Okay, so this is already a very dodgy memory address, right? 3C, that's the memory address. That's way too small, right? Memory addresses cannot be that small. Memory addresses are usually quite high. So what this tells me is that probably it's trying to find an offset from a null memory address. Now, I just happen to know this, but you know, let's see how else we can see if that's a true story or not. If I go a little bit up the call stack, okay, well, that was pretty quick. So this is actually null, right? So we are dealing with a null pointer. Acceleration structure is null. We're trying to call this intersect acceleration structure function, right? But the actual acceleration structure instance is null, right? And if we go up a little bit further, I expect we'll see this. AC should be null or empty. I guess it's like a unique pointer or a shared pointer. That's why it says empty and not null. But the point is this actual, if we look at the raw view, then you can see that we are pointing towards like a null pointer. So AC is null. Not sure why this has happened. One good thing you want to do almost immediately is actually look at the log. And you can see that did pay off because we can't load files. Again, right? Even though we fixed this scene and it seemed to load the scene fine, but it just can't seem to load anything else, right? So always look at the log in case the person who's written this code actually logs like error messages for file reading and stuff like that. I suspected it was like a missing file because acceleration structure is obviously the thing that holds like our vertices and our triangles so that we can do ray tracing with them, and it's null. Right? So probably couldn't load the mesh or something like that. So let's go up a little bit and see why I've already got so much to say about this code, but let's go a little bit higher. Let's see. So what do? We do main, we do render. So scene, I'm guessing the scene constructor probably ends up loading all of these files, right? So let's take a look at that. Load scene, we loaded the scene. And then we do root path. So root path is scene path, and then we find input, and okay, so we erase. Okay, let's put a breakpoint in here. By the way, another reason why it's important, I think, to fix projects that you get from GitHub if you're trying to learn more about them is because you can read the code and that's all fine, but being able to actually tweak the code, play with it, debug it, see how the code flows by placing breakpoints and then hitting them and stuff like that, that's a far better way to learn than simply reading the code, right? So that's why, you know, if you download a project, the code's there, great, but it doesn't work, that's also a very bad situation to be in. So yeah. Anyway, so we find we find input. So input slash shotgun scene is the actual. This should be like a debugging series, shouldn't it? Code review, more like debug review, or like, anyway, whatever. So man, okay. So we erase. Well, in this case, like, what are we even erasing? We just erase everything. So the root path is nothing. Root path.find input. Wait. Hold your horses. Let's go back to this. Does it really just wipe that? Hold on a minute. Hold your collective horses, everyone. Huh? Okay, right. So okay, no, it doesn't work. I thought what it might do is like just strip the entire path up until input, and then it's like, okay, that's what you mean, but that's also weird. Anyway, yeah, this does have a root path, and then I guess it sets the root path to be that, and then it tries to, like, it separates the scene path or something. It's all very weird. I'm not sure why it's written this way, to be honest. I think that, like, the way that the file system is working in this project is a little bit overcomplicated for not much reason at all, but you try to extract the root path because you expect an input directory from there. And then also, I think from the console, we could also tell that it looks a little bit weird because like, we're trying to load, like, why is there a leading slash here? That's a bit bad news. I mean, input objects, what do we have here? So like input objects, shotgun, yeah, like this stuff seems to exist, right? There's the shotgun obj, but this leading slash is probably ruining everything, so I'm not sure why that's happening. So let's go back. Another great strategy is to actually, like, this seems like a an actual string, is to just search for strings that you see printed in the console, because obviously I've never looked at this code before, I don't know where it is, but if I search for that, you can see I can find it. So load BMP, could not open BMP file, and then the file name. So let's just place a breakpoint in this function and work backwards a little bit. So file name is slash, okay, so there is a leading slash for some reason. I'm going to try and track it down. So this obviously comes in from here. And mesh, oh, okay, so it tries to do options root path plus this, and then plus this string value. Okay, and what's value? Input slash objects slash shotgun diffuse. Okay, so this value here seems okay, right? Input slash objects, I assume that's coming from the actual, where are we? I assume that's coming from the actual, like, shotgun.scene file, right? So we have input objects, shotgun, all of that stuff that's coming in from this file. However, again, this whole, like, root path situation, like, I'm not sure why this is here. I think I know why it's here. I think it's because, again, this person is trying to load everything in an absolute fashion. Because if we think back to what this used to be, right, the root path used to be like the absolute root of this project. So it was like D drive, dev, blah, 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 and then eventually ray tracing. So in that case, what they're doing is they obviously have decided wisely to not store absolute parts inside the scene file. So these are all relative parts, but they think that they need to like stitch them up with the absolute root to then be able to map this file and load it properly, right? Which I get that idea, but that's just not true. And in fact, again, it's much better to just set a working directory that is not absolute and then kind of see what's going on that way, right? If you really wanted to stitch them up for some reason, you could also query to get the current working directory, right? So if I wanted to, like, Here's what I could do, right? The correct fix for this probably would be to just remove all of this. Well, what I would do is I would remove all of this options root path. You don't need a root path, right? Unless, again, your assets directory is somewhere else on your computer. In that case, you probably will. But for this little ray tracing project, I would just remove this, and then you can just obviously use whatever value you've read in from that scene file. However, one thing you could do is, if you really want a root path, is actually set this root path to be std file system current, what was it, current directory. Let me just include file system, and then we'll see. So you could make it, I think it's supposed to be, yep, current path. You could actually get this, and then I guess as a string, assuming this is what you're storing as a string, yeah. And so if you actually do that, let's take a look at what that would give us. That would give us the root path of, like, that would give us our working directory, right? And if you stitch that up with everything else, such as, where were we trying to load the BMP file? Let's hit F5. You can see now we are looking at an actually real absolute path, right? So you could do that. Maybe that will work now. Yeah, it seems to work. Okay, I assume it's just very slow. So let's go ahead and run it in release mode, and maybe we can like see a frame or something. 71%. Ooh, there we go. Look at that. It even opened up the photo view on my computer. So we have a shotgun. Great. I'd like to see that other kind of reflection scene as well. But yeah, it looks pretty good, I guess. Looks like maybe something like MIP mapping could definitely be implemented, as well as anti-aliasing, because that looks pretty jaggy. But yeah, that's pretty cool. So you're rendering a 3D model. Looks like there's a bit of lighting going on as well. You mentioned, I think, normal maps, although it's kind of hard to see. No, well, no, there is clearly like a lot of bump going on here, which I assume isn't just from the albedo map. So yeah, looks pretty cool in general. Opening up in a photo app as well is pretty nice. The final kind of testing that I will do before we jump in and take a look at the actual code is I want to see if there's, I mean, what scene should I run? I think full scene.scene sounds juicy. So let's go ahead and try that one out. A little status update. I've been sitting here for about a minute. This is taking some serious time. It'd be funny if at 100% just like deletes system32. What am I doing with my life? Okay, finally, so we have this result. I don't know why that took so long, because the shotgun looks almost identical. I mean, there's a skybox and a sphere with like some reflection going on, but that's a bit weird. Look at that, 105 seconds, like 2 minutes almost that took. So that's quite a bit. Anyway, let's finally dive into the code and take a little bit of a look, and I'm going to see if I can criticize this to death. I love these things. Okay, so scene path. So okay, so let's talk about this, right? So I don't like this kind of pattern, right? If you're making a variable like this on the stack, there's nothing wrong with it per se, but I would much rather create it like this and then actually call render on it. The reason being that making an object like this, you're not really giving it like an L value. It's all kind of in temporary land, and then you're calling .render on it, and like the scope of this is kind of not really as easy to define, as well as if you wanted to have other functions that wouldn't really work. There's nothing really bad with this per se. It's not like it's gonna, you know, ruin your program, but it's just stylistically not something I would do. I wouldn't create an object on the stack like this and then call .render on it as if it was like some kind of chained function. That's not really how I would do things. I would create the variable like this and then call .render on it, which I think gives a little bit more scope to scene. But also, if you're doing stuff like this, it's almost like worthwhile to ask yourself, do I really need to make a class out of this? And do I really need to be like all object oriented about this? Again, nothing specifically bad about that, but you know, this maybe could have just been a function. Although I do kind of understand what you're doing. You're almost creating scene as a context with an actual file, right? And then you can, you know, use that file to do things with it. But again, because you have written it in one line like this, and this scene instance doesn't really exist for long, it also doesn't really make sense in a way, if you catch my drift. So yeah, I mean, I would totally understand it if you know, had scene, you set the path, that's kind of the context, it loads the file, and now you can do many kind of operations on it, like render it multiple times from different camera angles, and you want it to all revolve around this context. That, in my opinion, is a good use for like making a class out of it. But anyway, moving on to the scene, which is where everything begins. Let me take a look at what you've got here. Okay, so, all right. Nothing really too big to draw attention to here. This is interesting. We'll take a look at this in a minute. The thing that stands out to me immediately is that everything is public, right? So some of this stuff probably does not need to be public. You should probably hide some of this stuff and make it private, right? Either that or just use structs, because it looks like everything here is just all exposed, which is, again, totally fine. I don't really think that you need to be necessarily pedantic about private and public stuff unless you're designing an API. This is clearly just like a little project, so I'm not sure if that's even worth drawing attention to, but for everyone watching, you know, you'd probably want to not have some of this stuff here. One thing I really like doing that I didn't used to do in the past, I used to also just declare variables at the top. I think I was coming from Java and I was used to, you know, you kind of declare your variables at the top of the file. There is no header file, C++ kind of file in Java, but what I do these days is I actually declare the functions at the top, and then usually I have my private variables down the bottom. I know these are public variables, but same thing, almost same thing. So the reason I do this, and again, it might not make sense in this case because you have made everything public, so everything is kind of user-facing. But usually when you open a header file, right, the first thing that you care about is what can I do with this class? And usually that does not involve the private members that I can't even touch, right? And I mean, in this case, I doubt that you are going to be, you know, looking at this file and being like, oh yeah, I guess I'll play with the lights like this directly, right? Especially if you happen to like have functions for setting lights or whatever. So my point being that it's nice to be able to look at a class and the first thing you see is the API. What can I do with this class? You know, how do I call the constructor? What parameters does it take? That kind of stuff, right? That's why I like to reorganize stuff like that. Again, I'm just using you as an example here because obviously everything's public, so technically everything is user-facing and therefore maybe you would like to see this, but I still maintain that the constructor is usually the first thing you want to look at when you're dealing with like a class like this, unless it's like a structure of data and the constructor is there for convenience. Camera you've got here. Oh, okay, this looks like, okay, so you've made your own little math library. That's interesting. That's kind of cool. Let me just quickly breeze through this. Okay, so you got matrix 4x4. Okay, so basically everything you need for ray tracing, it looks like you've pretty much got that stuff here. Now, a word of advice to people doing this kind of stuff. I probably wouldn't write my own math library, right? Unless this was like the first time I've ever done any like graphics programming or mathematics and I really just wanted the experience of actually writing that stuff myself to learn more about it. That is totally okay, and in fact, I probably encourage that. But for the most part, right, I am going to assume that this specific project is about ray tracing, right? If you want to learn about ray tracing, you don't need to write your own math library. You definitely need to understand the mathematics behind it, right? But you don't need to, like, I wouldn't waste time making a math library, basically, is my point, right? Unless, as I mentioned earlier, you really want to because you've never done it before and you're interested in how math libraries work and you're kind of, this project is not just about ray tracing. But from now on, I'm going to assume this project is just about ray tracing. So in that case, I wouldn't use, I wouldn't write my own math library. I would definitely use something like GLM. Now, the reason is twofold. First of all, it's a tremendous waste of time, in my opinion, to implement all of these functions, make sure they work with different types and all of that stuff, right? Because it's much better to just learn the theory of how to use these functions, if that makes sense. The implementation is not really that important. The second reason, though, possibly more important, is that this is going to be much slower than something like GLM because this does not use any SSE instructions, right? So SSE is a way for you to be able to kind of execute, you know, certain mathematical operations like multiplication between matrices and between vectors and stuff like that a lot faster, because what you can actually do is load up these special registers on your CPU, like a 128-bit wide register, which holds 4 floats. You can load them up with data and then execute that kind of multiplication operation in a single instruction rather than 4 instructions, right, for each float. So that tremendously speeds up stuff. And something like GLM obviously implements SSE, right? They've written their math library with SSE support. It's also called Neon on ARM architectures. So the point being that, like, you know, unless you're gonna learn that, which actually is something useful, I think, to learn, to just be aware of how SSE works. And I mean, a lot of people don't even know that it exists. So it's really, it is definitely very educational. But my point is that, you know, instead of spending time on this, you could have spent time learning a little bit more about ray tracing. In fact, I think the topic of ray tracing is something that pretty much every C++ programmer should touch at some point. There's like this ray tracing in one weekend thing. It's like a little book slash website. Definitely recommend you guys check that out if you haven't already. It's a fantastic exercise. It's actually something I wanted to make as like a little video series on YouTube, just basically implementing that ray tracing in one weekend thing and talking about everything and maybe how we can speed it up and stuff like that. Let me know if you're interested in that, but that was an idea I had a while ago. But yeah, so those are kind of my thoughts on the idea of making a math library. Again, not that I'm 100% against that. I just think that in the long term, it's probably not something you generally want to do. So let's dive into the scene constructor and see how this works. So this.loads. Okay, so this is like another thing, right? You don't need to use the this pointer, right? The only reason you would ever use this pointer, really, like this, is if you had like, you know, you had a member variable called scene name and a local variable called scene name, and you wanted to specifically reference like the member variable, right? Then you would have to use this if they have the same name. Again, in my experience, you wouldn't have the same name because you would use like a convention like m underscore, and that would kind of fix that, as well as you'll be aware of your member variables versus local variables. And obviously the other use case is if you actually want like a pointer to the current instance for whatever reason, then of course you'll need to use this, or const if it's in a const function, right? That's pretty standard, but otherwise there's just no reason to use that, right? Just call the load scene function like this. Okay, so if enable output, then we output stuff. Okay, cool, road path, blah, blah, blah. Okay, and then you do a lot of, okay, a few things here. So you basically do a lot of parsing that kind of what looks to be a custom file. Another thing that I probably wouldn't do, right? Again, unless you want to learn about parsing and learn about how to make your own file format, which is totally legit, nothing wrong with that. But again, if your purpose is ray tracing, I would focus on that instead, and you could use a well-defined format like JSON or YAML. I would use YAML for this because it's a little bit more human readable, no like square brackets and curly brackets everywhere to keep track of, and commas. You know, YAML is really quite nice for like human readability and for a human to edit, right? So that's what I would do instead of doing this stuff, because you could use a library for that. You wouldn't have to write the parsing code yourself. And also it's just a more robust file format that can support a lot more things. You know, like looking at this, like, I don't know, are spaces implemented? What if a space isn't? And then I want to write this in quotes. Does your code handle quotes? Like, there's a lot of kind of problems with custom file formats, obviously, and a lot of little things that you might not take into account. So in the general case for most people, I would just use something like YAML. The other thing that's kind of standing out to me, let's say, is this kind of log error thing, right? So log error is obviously a macro that you've got going on here. And like, it's a little bit, okay, well, so let's talk about this, right? So the reason you're using a macro here, probably, is because you want to use these kind of preprocessor variables, right? You want to know what file it's coming from, what the function name is, and then also the line number, right? That's totally legit. But the thing is, I would write this a little bit differently. What you're doing here is you're kind of breaking C++ syntax, and it's actually causing some problems. So what I mean by that is, you know, because the preprocessor is literally just something that copies and pastes stuff, right, before we send it to the compiler, it means that we can really define things that break the C++ kind of syntax and style and stuff like that. So a good example is if I wanted to, you know, I could create a little begin and end keyword if I wanted to be more like some other language that has that. I think Pascal has something similar. But if I wanted to basically do that, I could write code like this, right? And that would be totally fine. It would compile, it would work. But the reason I don't do that is because it kind of breaks C++ syntax, right? Like if we're reading C++ code, we want to kind of be in the loop with C++. We don't want to do something that completely changes the language, usually, right? And so that's what I don't like about this function or this macro, right? What I would do instead is I would add some parentheses and I would get rid of the semicolon. It's a very, very small kind of change, right? But what that would mean is that instead of writing code like this, right, you would actually need to write code like that. And now that looks like an actual function call, and that makes sense, even though it's a macro. You can see my syntax highlighter is saying that it's a macro because it's purple, but also it's in all caps, and usually if something is capitalized, we usually use that convention for macros, right? We wouldn't have a function, you know, with this kind of naming convention or this kind of naming naming style, I guess. But anyway, so that's what I would do. The other problem though with the with what you've done here, which is not very good at all, is what it looks like is that if this is the case, you return result, and then it looks like you return, well, nothing at all if there was no error. Like this whole thing and this weird indentation, which I can see you don't have here, but this just looks bizarre, right? Because again, it's kind of tricking you. It's almost saying that like, well, if that happens, log error, but really the purpose of this if statement is to execute this, which again then results in no return, no variables being returned. What's actually happening here though, because you of course do have a semicolon at the end of this macro, what really is happening here is it's actually just doing this and then it's returning all the time. Right? I mean, look, even Visual Studio is confused as to the indentation of this because there's no semicolon here, and I guess it doesn't really properly evaluate that preprocessor. So it's all a little bit weird, and it breaks C++'s syntax a little bit. So what I would do instead is, first of all, never write one-line if statements. Maybe with the exception of if you have a conversion function and it's like if the string equals blah blah blah, return this enum value. You know, for stuff like that, I do tend to put it onto one line because it's more or less a conversion function. But for actual code flow functions like this, put them on 2 lines like this, right? Just do this, right? Why? Okay, let's talk about why. So first of all, the biggest reason why I like this, apart from readability, so in my opinion, this is easier to read, right? But obviously that's an opinion. But in terms of why I would actually do this, I think that the biggest reason is probably debuggability, right? So the problem with having your if statement on one line is that if I put a breakpoint here, what happens? Well, it's going to break when it hits this if statement, and then also if it hits the result or not. So at a glance, as I'm debugging, I don't know if this evaluates to true or false, right? If it is like this, very easy to see. If I hit F10, once this breakpoint has been hit, it's gonna jump to this. It's not gonna jump into here. So that already makes it easier. The other really good debugging thing that this allows you to do is actually specifically break on errors, right? So again, if this was all on one line like this, then I'm gonna break on every call of this if statement, which is useless to me because I want to break only on the error. This lets me put a breakpoint on this line and then only detect errors and then be in a state where I can debug why that was an error. Does that make sense? So that's what I would do instead of you know, putting if statements on one line, because it gives me that ability to kind of debug my code a lot easier. And I also personally just think that it does in fact look a little bit more readable. Now, I actually used to do one-line if statements like this when back like 10 years ago when I used to program in Java. But since then, I've definitely switched to this because I think it's just a lot easier to deal with. So yeah, so that's my kind of speech about your use of macros and also if statements. And hopefully you can see kind of why that's a problem and why I wouldn't do it this way. So that's all the whole parsing thing. Let's actually dive into some of the ray tracing code, and we will get on with this. The general structure of this code, as I glance through it, is pretty good. Like, I don't really have many issues with it. There are some stylistic changes that I would, you know, I write my code differently. Like, I would use curly brackets. I would open them up on a separate line. Again, when I used to write code in Java, I did used to do it on the same line. But since working with C++ and a little bit more in the professional industry, I think this is much more readable. So that's what I would do, especially because it is more or less like a C++ kind of convention. And usually I end up writing code, usually, not always, but I end up kind of matching my convention with whatever language, whatever the main convention kind of, or the main kind of style is for a language. Okay, so render work, let's kind of, where's the actual render function, right? Because I remember that was something that was called from the main function. So render, okay, so if scene load success return -1, okay, you're returning -1, but then you're not handling that. So that's also something that maybe you could print an error or like, I'm not sure, handle that. Also long, like, bro. We're way past that. You're specifically using C++ 17. That's what you said, right? So you are way past that. Stop using int, well, you can use int, fine. I'll let you use int. But long, I don't want to see that, man. If you want something to be a long, you use int64t, right? Or uint for unsigned long, right? Start using these types and stop using the kind of built-in types, right? Because these, obviously, the biggest difference here is that these have a size in the name. 8 bits, 16 bits, 32 bits, 64 bits, right? We know how big these are. They are guaranteed to be that size on whatever compiler, on whatever platform you're working with. This useless pile of garbage has absolutely no information about how big it is, right? A long on Linux is not the same as a long on Windows. A long on Windows typically is 32 bits, right? A long is 64 bits, which is why you see this defined. That's different on other platforms. So it's really just annoying, right? So just use these as much as you can. Int, in my experience, int's like always 32 bits. I'm sure there's probably not, but I've never seen int be not 32 bits or not 4 bytes. But so therefore, like I do use int from time to time, but I think if you want to be pedantic about it, you should just use these types for all of your integer needs, and that's it. So that's what I would do. I would not use long, right? That's definitely not a good idea. So we have a frame buffer. Okay, options height width. So this is our main frame buffer. This is that pixel array I was talking about, vec3. So we have like an RGBA, sorry, not RGBA, just RGB kind of float array of color values in here, which is what we end up outputting to that BMP file. Ooh, how are you outputting the BMP file? Save image. Ah, cool. Yeah, that's what I thought. So BMP is actually a really easy file format to work with, to the point where you don't need a library really to kind of, you know, write BMP files or read BMP files. You can see there's just a little header here, which you basically, so you have this header with a header size of 54 bytes that you kind of allocate here on the stack, and then you at particular offsets write in data, which is what we do for the BMP file format, and then you obviously basically copy across all those pixel values into that buffer, which is pretty cool, right? So it's really easy to do this. That's, again, something I expected you to do just because you also made your own math library and did all that stuff. So that's cool. It's nice to see stuff like this. It teaches you a lot about it. So I'm beginning to think this is more of like a general purpose educational programming thing and not specifically about ray tracing, but that's cool. And then what are you doing here? Shell execute open. Okay, so this is the code that actually opens up whatever your default Windows app is for looking at image files, which is why it opened up photos on my computer and actually showed me that resulting result of the ray tracing. So that's pretty cool. That's kind of just a little hunch I had. Okay, so anyway, so where is that render function? I keep losing it. Okay, here we go. Show AC. To show AC, we need to go another routine. What is show AC? Use AC. Show AC, use it. Okay, well, it's set to 0. Okay, bro, like bools, don't set them to 1 and 0, set them to true and false. Like, what's going on there? Come on. Yeah, that's interesting. Well, we didn't do this, so we won't do this, but maybe this is like somehow it, I don't know what this does. I mean, like, I'm just, like in regards to what this does compared to this. But anyway, launch workers is what happens. Launch workers. So if debug render work, in debug mode, we do not create any additional threads. Oh, man. Okay, so why? Why is this? Okay, okay. Where do I start with this? I would not do this for a number of reasons. First of all, I really don't understand why you would not multi-thread this in debug. Like, that doesn't make any sense to me. If you really wanted to have a single threading mode, well, just have like, you know, if single threaded, then whatever, right? That makes a lot more sense. Or you could even have it as like a runtime variable. Not necessarily, you don't need to make it like a preprocessor thing and then recompile your code if you want to switch between the two modes. But my point is, so first of all, debug is already slow, especially for stuff like CPU side ray tracing. Debug is a lot slower on the math side of things, right? So because of that, you're already kind of shooting yourself in the foot with trying to get any kind of good performance. I mean, I know you're more about like seconds per frame here instead of frames per second, but my point is that that's why I couldn't even run it in debug mode. I had to switch to release immediately, which presents another problem. What if I have an issue that I'm trying to debug? Well, I have to sit through like, you know, 5 hours of waiting for stuff to render before I finally hit my breakpoint on like this in this kind of lighting pass or whatever, or this reflection pass iteration or whatever. You know, when I'm tracing that ray and I want to debug it, like it just makes debugging a lot harder. Also, what if I'm having multi-threading issues? What if I'm having things that are weird race conditions that I want to maybe debug by putting a breakpoint in and seeing what thread ends up calling that? Like it's just a bit of a mess, right? And I can't do that because apparently I only multi-thread in release. So that's a bit weird to me. Like, I definitely wouldn't do this. Try and keep your code more or less the same in debug and release, unless of course there's extra code like error checking that you want to do only in debug. That's totally valid. But changing the whole architecture of everything between debug and release is a bit weird. So I definitely wouldn't do that. Okay, so this calls, okay, so it ultimately does the same thing, right? So 0 and, what does this function take? Frame buffer, y0, y1. So that's, okay. Okay, I see, right. Okay. So you've split the, I guess you've split it into vertical strips. How many threads do we have? 8. Joke's on you, I have 16 cores and 32 threads. But anyway, so we've split it up into 8 threads, and they're working on these kind of vertical slices of the image, right? So this is actually kind of similar to what we looked at last time with the voxel engine. However, it's obviously doing ray tracing instead. Although I guess maybe the voxel thing could be perceived as some form of ray tracing, maybe. Well, it's more like ray casting, I guess. But anyway, whatever. That's what we're doing here, right? As opposed to this, in which we go from 0 to height, right? So we go from, oh, maybe we're doing horizontals. No, we're probably doing horizontal slices. I don't know why I thought vertical slices. From 0 to height, yeah. We're doing horizontal, which is better anyway. You usually want to do that. Tiles would also be interesting. But anyway, so we go all the way from 0 to height in a single pass versus splitting it up into 8 different sections and working on them simultaneously, which is what the purpose of kind of multi-threading this is, I guess. So again, wouldn't do that. I would definitely run it multi-threaded in both debug and release. Let's dive into this a little bit. Okay, so you have a thread pool, which is cool. You have a thread pool of unique pointer threads, which you're creating here. Again, no reason to do that, right? Instead of doing this, I would make a thread pool of just threads, because I don't really see why you would want them to be unique pointers, right? So unique pointers obviously can't be copied, same as threads. I'm pretty sure the thread copy constructor is disabled. So let's just say, okay, so let's just say I did this. Let's actually move this down. Yeah, so what I would do ultimately is have a thread pool, let's call this Cherno pool, that's like this, right? And then, so if I try and copy this to here, I'm assuming, yeah, so that won't work because the copy constructor has been deleted, but I can still move it just, yeah, thanks, bro. Just like is what's happening here. You can't copy unique pointers, but you can move them into this vector, which is what's going on here. In fact, we can see that it's specifically the move, the R-value reference version of pushback that's being used here, right? So in terms of like copying and moving stuff around, you can do whatever you can. You can do whatever you want with thread, as with unique pointers, right? But also, yeah, I just don't see any reason why you would ever use unique pointers here. I mean, you only have 8 instances of them, so it's not like the heap allocation cost is going to be like something that you'll even see. But I just think that like it's in general, it's good to get into the practice of just not heap allocating whenever you can avoid it, right? So just try and allocate stuff on the stack as much as you can, unless there's a specific reason why you need it to be on the heap, right? A lot of people see unique pointers and smart pointers as a way that obviously they hide that new kind of call, and so it looks like maybe it's not as scary or not as bad, but obviously they're still calling new. I would definitely just make a vector of threads like this. So yeah, so that's the only thing here. But it's good that you're not creating these every frame. I mean, you don't have the concept of frames. You just launch this and you finish your render, and then that's it. The application terminates. Yeah, but in general, it's nice to have a thread pool, which you then wait for every thread to join, obviously. So you wait for every thread to complete its rendering before you actually bounce back to this code and return 0. So that's fine. Finish brackets dot load. So what's this? Oh, okay, so you're using atomic variables for statistics. So I'm assuming each of these workers, when they finish, they write. Okay, so I wouldn't use load, right? I would just use, with atomic variables, you can just use them as normal variables, like as if they were just that, right? So there's no real reason to use load. There are technically some differences between load and not using load, but in this case, you're not going to see any difference. So I would definitely write the code just like that, because it's just a little bit easier to read. You don't need the load function everywhere. But other than that, like, good, you know. Obviously you don't want a case in which you try to write to one of these variables simultaneously, so atomic is a good fix for that. And then, okay, I see. So this is basically just you on the main thread. If output progress is set to true, you just have this like little loop that basically prints. How long does it sleep for? Like 10 milliseconds in this case. Okay, whatever. You just have this like little loop here that basically at a fixed time interval, it looks like, it just outputs the percentage of, that's what we saw, that's where we saw the percentage being output, like when it said 94%, whatever. That's happening here. So on the main thread, again, which is, you don't need to like lock this log lock. You don't need to log because we're on the main thread. We're only printing stuff from the main thread. For anyone else there who might be multi-threading stuff, just remember, if you are printing from multiple threads, like cout isn't thread safe, so you want to probably have a log function and then have like a little spin lock that you basically lock that function so that you can't call it from multiple threads at once, because then you'll get stuff printing in the middle of other stuff. And yeah, so but doesn't apply here because we're only doing the printing on the main thread, which is cool. So this is a nice little system. And then we join. So finally, last thing we'll look at today. This is a very long video, but I don't know, this is just what I'm doing. This is just me. That's just what I happen to be doing today, looking at this for an hour. So render worker. So we get a frame buffer. We have this like, you know, kind of region here on the y-axis that we've decided to render to, and then I'm assuming, yeah, we do like cast array. We get array from the camera based on where we which pixel I guess we're working on, and then we do, so again, you know, multiple line. I would drop your little if statements here, especially if you seem to be doing it sometimes. We have a little show normals thing, which is cool. I mean, again, I'm not really going to get into like the algorithm of ray tracing. If you guys are interested in that, then I'll leave a link in the description to the ray tracing in one weekend thing, because that's definitely a good read, and it's probably good for everyone to read. But yeah, I mean, this just looks like pretty typical. So you got area lights. So area lights, and these are all kind of pointers because I think that's probably, okay, so you have a light hierarchy. Kind of like, I guess that's why I saw that object pointer as well. I guess object is also a base class for a lot of things like triangles, meshes, and spheres and stuff like that. I assume, yeah, there's sphere. Okay, I mean, that's reasonable. I don't know if I would hierarchically kind of structure it with inheritance and stuff like that if I was doing it. It's just a stylistic thing. No real reason not to, I guess. And I'm assuming that these things do in fact have different functions like set points and illuminate. What does that do? Nothing. Yeah, I think one thing that I probably wouldn't do as well is have these functions like, you know, directional or distant light. Distant light, interesting. Definitely looks like a directional light, although it does have a point that is unused. Yeah, I guess I get why you're doing that. It's because lights are different types and you have a different illuminate function for each, but I think I would try as much as possible to contain the algorithm within like the function, right? I think the only real reason that you would want to maybe bring stuff out into functions is if you want to like specifically avoid code duplication. That's very valid, and that's where you would do that. Like, you don't want to be copying and pasting the same code multiple times but changing parameters. That's what functions are for. But, you know, sometimes people tend to break stuff up into functions or into classes for no reason, and it actually makes stuff harder to read, because instead of looking at this screen like I am right now and seeing the whole algorithm, I have to jump to this function and then be like, ugh, but what light type is it? You know what I mean? It just makes stuff a little bit harder to read. So that's why, like, I would maybe avoid that. Not to mention that if it'll be a virtual function call here, which isn't a big deal, but potentially worth being aware about. So I would try as much as possible to just contain the algorithm within this function, or again, with code duplication, you know, maybe bring it out into other sub functions that are also kind of in this file. And I would call this file like renderer.cpp. So that's probably what I would do if I was doing this. Maybe I will when I do that ray tracing in one weekend video series. But yeah, other than that, like, yeah, you've just got some kind of basic like rendering equations here. There's nothing too like complicated with this, I think. Nothing I can see from the code, nothing I can see from the result, really. You're just basically shooting out rays, seeing what they hit mathematically, what they intersect, what the color should be based on the material on the surface and stuff like that, reflecting rays and refracting them for certain glass types, I guess, because I think I saw refract. Yeah, refract, compute refraction, and this is for like transparent material, so if you've got like glass. So yeah, so overall, yeah, pretty cool little project. Definitely a lot of things I would probably change if it was me writing it, as well as I would definitely try and kind of make it real time. I'm more of a real time rendering programmer, but I do still love ray tracing, and I think that you could definitely start to maybe move this stuff into like a compute shader, or even keep it CPU, but kind of make an application out of it that you can actually see the result with and play around with like where the camera is and stuff like that. That's where I would probably take this next if you were serious about kind of making a ray tracing engine, because that's obviously something that's possible to do, and also I think a lot of fun. But generally, I don't have that much, like, I mean, apart from what I've said, I like the structure of your project. Actually, one thing that kind of caught my eye when I glanced at like the source directory is like you've only got 5 CPP files, and like they're pretty big, like well, they're not that big, but 31 kilobytes, 25 kilobytes, like this is good. You know, a lot of code that I look at has 3 times the number of files, and they're all like 2 or 1 kilobyte, right? That's really annoying for me to look at, and I don't like that. Like, I think I remember back when I worked at EA, I looked at Frostbite, and I'm pretty sure that like the entire DirectX 11, I think, renderer that Frostbite had, like all of the API calls to DirectX 11, at least back in the day, they were all in one file. Like they were just a file called DX11 or DX12 or whatever, and they were just all there. Like literally the whole renderer, it was like 20,000 lines or something like that. The whole kind of back end for that API was in a single file. And I looked at that, I'm like, man, this is amazing. I thought I would have to spend like hours looking through the whole code base, and you don't want to look through the whole code base, man. There's like 250 projects in the Visual Studio solution, I think, something like that. Like you don't want to look at the whole, like there's a lot, it's very complex, right? But seeing that was like, it was almost like a light shining from above that was just like, it's all here, man. You just look at the whole thing here. Like you don't have to open more than one file, literally. Like, it's amazing. So I really like that. I really like that approach to software. Again, sometimes you could argue it doesn't make sense. I agree. I'm not saying you should have main.cpp and that is the end of that. I'm saying that trying to minimize separating all of that stuff out and abstracting stuff in like an OOP way, which is what so many people love to do, right? I think that dramatically helps pretty much everything. Anyway, I hope you guys enjoyed this video. Please don't forget to hit the like button if you did. chernoreview@gmail.com is in the description, and that is the email address where you can send me your project. If you guys have any suggestions for projects that you want me to look at, I've been looking at a lot of like rendering related stuff. This is just stuff I'm naturally interested in. I mean, we haven't looked at ray tracing before, but like if there's something specific that you want me to take a look at, I know you don't really know what emails I receive, but still, if there's a topic, just write a comment below, send in that email with whatever project you have and you want me to take a look at. Don't forget to check out Skillshare using the link in the description below, and I will see you guys next time. Goodbye.